Hello, everyone. So I'm Babak. I'm the project coordinator of NexaSphere from Safran Passenger Innovation in Germany. And NexaSphere is one of the projects of Stream B0103, and everything is about unification of TN and NTN and integration of radio optics. So going to the next slide, as we can see, among all the requirements for development of the 6G technology, we are focusing quite a lot on integration of radio and optical networks in order to make a unified terrestrial and non-terrestrial networks. Here in NexaSphere, the plan is to reach to TRL level 4 up to 5 for some of the use cases, meaning that we will have at the end of the project technology validation in the lab. And for some of the use cases and technologies, we will go one step further to demonstrate them in a related environment. In order to do that, we defined 3 main proof of concepts from that focus quite a lot on transportation, from aviation to the railways and automotive, which all these proof of concepts are using different technologies, wireless technologies, satellite mobile network and optical network, and the project focused a lot to make them unified and integrate to provide the seamless and robust connectivity to transportation sector. So here we see like an overall overview of the system. We are targeting like 3 different layers from the ground segment with automotive and trains as proof of concept, as well as all the terrestrial networks that are located on the ground. Then we are also having some objects in aeronautical sectors, and finally in the space sector, there will be satellites in which we are targeting both LEO and GEO satellites in order to create kind of multi-constellation, multi-orbit communication. Beside all these 3 sectors, we also integrate a kind of network orchestrator and management in which different management and orchestration can be done to all segments of this 3D network. So in order to like perform the goals and reach to achieve the best of the NexaSphere, all the partners of the consortium was selected very carefully. Each has expertise in at least one technology that we are targeting in this project. So overall, we are having 18 partners across 9 European countries with a total budget of around 8.5 million euros, and the project has a 36 months duration. I'm the project coordinator of NexaSphere beside Thomas De Cola from German Aerospace Center that act as the technical manager of the project. So the distribution of the partners are more or less equal, with 1/3 of the partners coming from SMEs, and the other 2/3 are distributed between large industries and research institute, as we can see in the picture. Overall, the project is having 7 work packages, with work package 1 and 7, the non-technical one, targeting the project management and impacting visibility and some standardization activities. In the work package 2, we are designing the overall system architecture, which serve as an input to all the technical work packages from 3 to 5. And all of them from 2 to 5 will provide the technology that is going to be demonstrated at the end in our main 3 proof of concepts that we introduced. But overall, we divided these main technical work packages in 3 different categories. In the first one, which is work package 3, we focus a lot on the component of the network, starting about the wireless optics for both long-range free space optics toward short-range Li-Fi components. And they are all like targeting also to design a kind of sustainable optical networks. Second, we develop and prototype some kind of NTN antenna for the 3 proof of concepts from aviation to trains. These antennas are multi-band antenna targeting Ka/Ku and should technically work with multi-orbit multi-constellation. And also we will have like another prototype of the antenna for the automotive proof of concept. And finally, we are targeting the disaggregated RAN by distributing the parts of the G node B across the our 3D network. In the second work package, instead of components, the focus is very much on the algorithm and some development of the software, which multi-connectivity is a highlight of this work package, because in NexaSphere, we are dealing with different links, from the optical link to different kind of terrestrial and non-terrestrial, different bands. Some of them are 3GPP and some non-3GPP. So multi-connectivity is the main focus of this work package, which will come with some AI models that will help the network to be more sustainable by doing some predictions. And finally, before or at the same time with the proof of concepts, we are also integrating everything in a larger scale simulation to have some initial analysis and understanding how the network will act in a larger scale environment. The last technical work package before the proof of concept is focusing on development and design of a TN 3D edge cloud continuum. This continuum is also equipped with AI-driven orchestration and management in order to provide the best resource provisioning across the 3D network. And so all these works that we saw in the slides will be served as an input for our proof of concepts, which is the use case integration, validation, and demonstration. So here, the three large industries, each focusing on one transportation, will lead the proof of concept. The first one that we in Safran will lead is mainly on aviation, and the idea is to provide a kind of broadband internet connectivity to passengers from like onboard the airplane, gate to gate. And then to do this, we also extend the communication for onboard by integrating Li-Fi for short range optical networks with 5G and Wi-Fi. And for the offboard, we are also targeting different satellites and different orbits. In the second proof of concept, Stellantis is leading the automotive, and this proof of concept is very much focused on AI algorithm by providing some predictions for the maintenance of the cars and some predictions for electric vehicle range, as well as they integrate the unified TN and TN in order to provide connectivity to the cars even in the remote areas. And the last one, which is leading by network rail, is focusing mostly on train onboard connectivity, which is the integration of TN beside NTN, so that they can have the full connectivity to the passengers through the whole route of the train from the departure station to the arriving station. And with this, I finish my presentation for the NexaSphere. And if you want to stay up to date, you can always follow our LinkedIn page that you can see here.
All right. Thank you very much, Babak.